Okay, we're talking about dilutions. We're going to talk about the theory behind it and then the mathematical calculation that goes with it. So the big idea is that solutions concentration can be described mathematically in a variety of terms. We've already looked at concentration described in molarity as moles per liter. So now we're going to look at what ways can we quantify the concentration of solution. So we're really going to be looking at the initial solution, and then we're going to be looking at the final solution, and we're going to refer to it as solution number 1 and solution number 2. We're going to see how they differ with their concentration, aka their molarities for it. So let's talk about the difference between the two again. So remember, a concentrated solution has more solute per given solvent. It has a higher big M molarity, and that could mean that it has a darker color for it, especially if we're doing a solution that has a color. Now, this is not always reliable because if you have a clear solution, you're not going to be able to see the difference between the two. So remember, a concentrated would have a lot of salt. I know that's not very a technical term for it, but if we think about that it has a lot in it, that means a lot of solute per liters gives it a higher molarity. Now our dilute solution, our opposite, is going to have less solute, aka a lower big M. It could be lighter, the same way it's not reliable if you have a solution that's clear, and a lot of times we refer to our diluted one as a watered down version of it. So if we have the same amount of liquid between these two beakers and one has a lot of salt in it versus a little bit of salt in it, that's how we can conceptualize our concentrated versus our dilute. Now, which one would be the more concentrated one out of the two? So we have solution number A and solution letter B. So we would see that B would be the higher concentrated because it has a darker color to it. And this is just looking at iced tea powder, and we were dissolving it. That's why you see a little bit of condensation on the glass here, because we were just seeing which ones dissolved faster for it. So we would see that the darker color would be an indicator for this, that would be a more concentrated solution. Now, how can you take a concentrated solution and make it weaker? So we have a concentrated solution. It's too concentrated. How do I make it dilute? We're going to see that to dilute it, we're going to have to add more water to it. They're going to have the same amount of solutes per it, but we're going to fill in the extra space and dilute it with water. So conceptually, what would happen to the concentrated solution as we dilute it? And this is called a series dilution. We take a little bit from our stock solution, or the one that has the higher molarity, and then we add a little bit into here, filling the rest with water. Then we can add a little bit more into here, add more water, add 1 drop over here, and then add more water for it. So before, we're going to have our higher concentration, and then when we add more water, we're going to have not only a higher volume, but a lower concentration. The amount of moles would stay the same for it. If we notice our particles, we just have more water per that given space. So mathematically, dilutions, how can we take one that's concentrated and make it weaker? We see we have M1V1 equals M2V2, and this looks very close to what we looked at for Boyle's law. And what we're going to see is that if we have 4, so count at 1, 2, 3, 4 variables, at least 3 of them have to be given. The 1 represents our concentrated solution, so the higher molarity, and our 2 represents our diluted one. That's going to be our lower molarity. Or I like to see whatever one you're going to see first in the problem, whatever you see second, and then you're going to see the number of moles is reduced from number 1 to number 2. So let's go through example number 1. How much of a concentrated 5 molar solution would you need to dilute it to 250 milliliters of 2.2 molar? So if we go through, we're going to find our first molarity is 5 molar. So we're going to write 5.0 here. Would you need, we don't know that volume that goes with it, to make 250 milliliters, and then we have our second molarity is 2.2. So the cool thing about dilution, we have our M1V1 equals M2V2. It doesn't have to be in liters, it could also be in milliliters too. So I'm going to label it on top, M1V1, M2V2. So we're going to have 5.0 for our M. We're going to have X here because I don't know that volume. We're going to have 2.2 here, and then we're going to have 250 here. So we'll see we have 5X on this side, and then we're going to need our calculator. So we'll see that we need to multiply 2.2 times 250, and we get 550. Then we need to solve for x. We divide both sides by 5. So 550 divided by 5 is 110. So we would see we need 110 milliliters of our stock solution. So what does that mean? Wow. What we see here is if we had a beaker, 110 milliliters would be the 5 molar. To make it 2.2 molar, we would have to add water. Well, how much water to get it to 2.2? Well, we would take the final volume minus the original, and we would see that we would have 140 milliliters of it would need to be water. And that's how we would do a dilution as per our dilution equation. So what does it mean? Well, we would have that 110 of our stock solution, that 5 molar, and then we would have to add the rest of it. So remember, we had 250 minus 110 would give us our 140 milliliters, which would just be the water. So thanks for watching this video on dilutions.